Download this code from codegive.com, link in the description below. Avira bug POC, broken authentication in two-step verification, 2FA. This tutorial explores a hypothetical proof of concept, POC, demonstrating a potential vulnerability in Avira's two-factor authentication, 2FA, implementation, leading to broken authentication. We'll cover the concepts, the potential flaw, the exploit methodology, and code examples. Disclaimer *: this tutorial is for educational purposes only. Attempting to exploit vulnerabilities in systems you don't own or have explicit permission to test is illegal and unethical. This POC is hypothetical and may not reflect actual vulnerabilities in Avira's current systems. Do not attempt to use this information to harm or compromise any system. Always follow ethical hacking practices and responsible disclosure principles. 1. Understanding 2FA and its implementation. Two-factor authentication, 2FA, adds an extra layer of security to the traditional username and password login process. It requires users to provide two independent factors of authentication. Something you know password. Something you have one-time password, OTP, generated by an authenticator app, Google Authenticator, Authy, etc., SMS code, or hardware token. A common 2FA implementation using an authenticator app works like this. 1. User enrollment *: the user enrolls in 2FA, typically by scanning a QR code containing a secret key. This secret key is shared between the Avira server and the user's authenticator app. 2. OTP generation *: the authenticator app generates a time-based OTP, TOTP, using the secret key and the current time. The OTP is typically a 6 to 8-digit number. 3. Login attempt *: the user enters their username, password, and the OTP generated by their authenticator app. 4. Verification *: the Avira server receives the username, password, and OTP. It validates the username and password against its database. Then, it calculates the expected OTP using the same secret key that was shared with the user during enrollment and compares it to the user-provided OTP. If they match, within a small time window to account for clock skew, the user is authenticated. 2. The hypothetical vulnerability, time-based OTP guessing and clock skew exploitation. The potential vulnerability we're exploring lies in the way Avira might handle clock skew and the potential for brute forcing OTPs within a wider than necessary time window. Here's the breakdown. Clock skew *: the Avira server needs to account for slight discrepancies between the user's device time and the server time. This is typically done by accepting OTPs that were valid a few time intervals before and a few time intervals after the current server time. For example, if the OTP time interval is 30 seconds, the server might accept OTPs that were valid 30 seconds ago, valid now, and valid 30 seconds in the future. The flaw *: the potential vulnerability arises if the Avira server uses a too wide time window to account for clock skew. Let's say it accepts OTPs valid for -5 to +5 intervals, 5 minutes with a 30-second interval. Lacks sufficient rate limiting on 2FA attempts. Uses short, example 6-digit, OTPs, making brute forcing feasible. Does not implement proper account lockout after multiple failed 2FA attempts. 3. Exploitation methodology, hypothetical. If these conditions are met, an attacker could attempt to brute force the OTP within the extended time window. The attacker would iterate through all possible OTP values for each time interval within the window and submit them along with the valid username and password. 4. Proof of concept, POC, code example, Python. Explanation asterisk. Asterisk configuration asterisk the code starts with several configuration variables. Asterisk username, password, the target's username and password. These must be valid credentials. Asterisk login underscore URL, the URL for the initial login page. You'll need to inspect Avira's website to find the correct URL. Asterisk OTP underscore URL, the URL to submit the OTP for verification. This is a crucial URL to find. Asterisk time underscore window underscore seconds, this simulates the extended time window the server might accept. This is the critical value. Start with smaller values and increase it. Asterisk OTP underscore length, the length of the OTP, typically 6. Asterisk rate underscore limit underscore delay, important for avoiding immediate IP blocking. Start with a higher value and reduce it gradually until you start getting errors related to rate limiting. Asterisk login, function asterisk. Asterisk authenticates with the given username and password. Asterisk uses requests.session, to maintain cookies across requests, as session management is often crucial for authentication. Asterisk crucially, it analyzes the response text to determine if the login was successful and if 2FA is required. You need to carefully inspect Avira's login page to understand how it indicates successful login and 2FA requirement. Update the conditional statements accordingly. Asterisk generate underscore OTP underscore range, function asterisk. Asterisk this function generates a range of OTPs to test within the extended time window. Instead of generating TOTP, it generates all possible OTPs for each second of the interval. This is important for a brute force attack. Asterisk attempt underscore 2FA underscore bypass, function asterisk. Asterisk submits the OTP to the OTP underscore URL. Asterisk analyzes the response text to determine if the 2FA bypass was successful. You must inspect Avira's 2FA verification page to identify the strings or indicators that signify a successful bypass, example a welcome message, a specific redirect, or a successful API response. Update the conditional statements in this function to match the actual response. Asterisk main execution block asterisk. Asterisk creates a requests.session. Asterisk calls the login function to authenticate and obtain a session. Asterisk if the login is successful and 2FA is required. Asterisk calculates the time range based on the time underscore window underscore seconds. Asterisk generates OTPs using the function generate underscore OTP underscore range. Asterisk iterates through the OTPs, calling attempt underscore 2FA underscore bypass, for each. Asterisk includes a time.sleep, call for rate limiting. This is critical to avoid getting your IP blocked. 5. Important considerations and next steps. Asterisk target website analysis asterisk the success of this POC hinges on understanding how Avira's login and 2FA verification pages work. Use your browser's developer tools, network tab, to inspect the HTTP requests and responses during the login and 2FA process. Pay close attention to asterisk the exact URLs for login and 2FA verification. Asterisk the names of the request parameters, example username, password, OTP. Asterisk the format of the request, example application/xwww formerly encoded, application/JSON. Asterisk the HTTP status codes, example 200 OK, 302 redirect, 403 forbidden. Asterisk the content of the responses, the HTML or JSON returned by the server. This is how you determine if the login was successful or if the 2FA bypass worked. Asterisk error handling asterisk the code needs more robust error handling. add try, accept blocks to handle network errors, HTTP errors, and unexpected response formats. Asterisk rate limiting asterisk start with a conservative rate underscore limit underscore delay, example 1 second, and gradually decrease it until you start encountering errors related to rate limiting, example 429 too many requests. Asterisk account lockout asterisk if Avira implements account lockout after multiple failed 2FA attempts, the POC will likely fail. Check for this behavior by intentionally entering incorrect OTPs multiple times. Asterisk TOTP implementation asterisk the code currently generates all possible OTPs for each second. If the actual TOTP generation is different, using a secret key and HMAC SHA-1, SHA-256, or SHA-512, you will need to implement TOTP generation logic in the code. In this specific case, since the goal is to brute force due to a wide window, we generate all possible OTP instead. Asterisk CAPTCHA / anti-bot measures asterisk Avira might have CAPTCHA or other anti-bot measures in place to prevent automated login attempts. If so, you'll need to find ways to bypass or solve them, example using a CAPTCHA solving service. Asterisk legal and ethical considerations asterisk remember, this is a hypothetical POC. Do not attempt to exploit vulnerabilities in systems you don't own or have permission to test. Unauthorized access and exploitation are illegal and unethical asterisk. 6. Mitigation strategies, from Avira's perspective. If Avira were vulnerable to this type of attack, they could implement the following mitigation strategies. Asterisk tighten clock skew tolerance asterisk reduce the time window for accepting OTPs to the absolute minimum necessary. Asterisk implement strong rate limiting asterisk aggressively rate limit 2FA verification attempts. Consider IP-based, account-based, and device-based rate limiting. Asterisk implement account lockout asterisk lock accounts after a certain number of failed 2FA attempts. Asterisk use longer OTPs asterisk increase the length of the OTP to make brute forcing more difficult, example 8 digits instead of 6. Asterisk implement adaptive authentication asterisk use machine learning to detect suspicious login patterns and require additional verification steps. Asterisk regular security audits asterisk conduct thorough security audits and penetration testing to identify and address potential vulnerabilities. Conclusion. This tutorial presented a hypothetical POC demonstrating a potential vulnerability in Avira's 2FA implementation related to extended clock skew and brute forcing. Remember that this is purely hypothetical, and it's crucial to understand the ethical and legal implications of vulnerability research. By understanding these potential vulnerabilities, security professionals and developers can build more secure systems and protect users from potential attacks. Always practice responsible disclosure and ethical hacking.